Shell patterns are strings with special combinations of symbols used particularly for information searches. Usually such patterns are used by string searching algorithms for find or find and replace operations on strings or for input validation. It is a technique developed in theoretical computer science and formal language theory. Although they may look difficult to be read and learned at the first glance, their utility and the efficiency of the process that uses them are beyond any comment. So we are about in this lesson to identify and recognize some simple shell patterns, to make use of more complex patterns for file name generation, and to use patterns and expressions to match data. The patterns listed on the slide are typically used for file name generation. Most likely you have already met the first two. They're the elementary approach in using file list commands from UNIX directories. Perhaps the next two of them would give you something to think about, but after all they're quite intuitive. Let us give a closer look to some simple shell expressions. The reason for which they have evolved and are thoroughly used is their power for matching strings. This is why you will see in the comments from the right column the term matches. Patterns are commonly referred to as wildcards. For instance, patterns can be combined for more flexibility. The patterns you're looking at are a bit more complicated than the ones discussed on the previous slide. We're talking here about expression constructs recursively used throughout a longer string. So starting from a root string, we can actually find combinations of it within a more complex structure. The way I see it, the descriptions on the right side are pretty much explicit. Given the fact we got used to using the star characters for finding files, the same rule can hereby apply, with the difference of these parentheses around the root string rather than using a single symbol. Moreover, we can now enrich our wildcards list with some extra handlers: the plus, the at, the question mark, and the exclamation symbol. Note the use of the latter for exclusion matches. Now, where exactly are we supposed to use these patterns? Imagine you're launching the file list command with the long display format option, and at the end you gracefully place the star. Your screen will be filled with a list of files and a whole bunch of attributes. Now, behind this outcome is the shell's command interpreting process. If you remember our first lesson at the 7th step, we learned about expanding meta characters to arguments. What we're actually dealing with here is the property of some shell utilities or shell scripts to take entire lists of files as arguments. Another opportunity of seeing patterns in action is conditional testing using the case structure or the if-then construct. As I would expect, you're probably aware they're helping to test some strings in order to promptly trigger distinct branches of execution. What few Unix users may know is that most of the shell programs can use patterns as well. So let us try a simple script as our first example. A script which implements a conditional test using the case structure. Thus, on your screen, this batch is pretty much visible. You are facing a variable which is repeatedly refreshed from the console input. Then its content is matched against several possible strings of various forms of yes, no, maybe, using several shell patterns. Good to go. The shell patterns that we saw on one of the previous slides can very well be used as bricks for composite expressions. Let us admit shell patterns with a greater complexity, as one can see here. So these constructs of shell expressions, which you're watching here, allow a great flexibility in filtering file names or matching strings. In this slide, we have a larger series of examples which better illustrate simple usage of expressions. For instance, we can see in the first two of them string combinations as fragments of a larger string. In these ones, we got combinations of a string and character classes, and we end up with exclusion patterns which make use of the already known exclamation mark as the universal negator. Please keep this list on the reach of hand. It could later serve as an expression referential. Now let us consider this working scenario. We have a generic application operating within a directory full of files. Here are approximately 100 files grouped in several categories: data lookup files, data input files, output files, temporary storage files, and so on. As you can see, a list long enough to fill in several screens. So behind the scene, one transforming process will occur several times, each time triggered by a manual command. A few seconds after each launch, some files containing the final results will be modified, while other files will not be touched as they contain the running context parameters. Each time we will be willing to examine these particular files, which are the object of our current manipulations. Therefore, one of the versions marked in red will be alternatively copied over the working instance, hereby shown in green, so that the application will use different context data for each launch. Okay, so far this is the operating context. Now, what I'm trying to say here is that we need the list of group of files, which in turn have very different names with little or no common root, and that in only one strike. Would you think this is possible? Well, with shell patterns it is. We will set the parameters of a file list command, which will enable us to see our targeted files in one screen. One first example of such a command uses the basic concatenation of character classes as individual character markers in fixed place. So here it is. In order to find such an expression, I had to pre-calculate the possible occurrences of letters for each individual position in the whole list of names of our files. The output indicates that we did the right choice. So now, out of the dozens of files within our working directory, I only bring on screen the ones which I need to check. However, this isn't the only way to use shell patterns. I also have another formula, a command with an easier to read argument. The character classes are here replaced with alternative expressions. It is more comprehensive, isn't it? So after all, we can validate both of them. They're sufficient enough for our exercise. Before we close the subject, I would like to propose a final exercise. Please build a shell pattern to match the strings quit, buy, and exit. I would suggest for a first trial to use alternative expressions. So here we go. Now that we've seen it, let us try the other solution, the one using character classes. Okay? Let us not stop here and pull another stunt. Try to list within your current working directory the files whose names begin with a point. Right. Do you have the solution? If you are in a hurry, you could use this one.